Have you ever wondered how your search engine just gets you, or how your grammar checker somehow knows exactly what you're trying to say? Well, today we're pulling back the curtain on two incredible AI models that made all of that possible, BERT and its leaner, meaner cousin, DistilBERT.
So before we jump into the models themselves, let's just think about the fundamental challenge here. I mean, how do you even begin to teach a computer that when someone says, "I'm feeling blue," it has nothing to do with color and everything to do with emotion? You see, it's never just about the words. It's about that whole complex web of meaning that connects them all together.
Right. Imagine trying to read a mystery novel one word at a time, with absolutely no memory of what you just read. That's kind of how the early AI models process language, talk about digital tunnel vision. But what if a model could absorb the entire sentence, the whole context, all at once? Well, that's the massive leap we're about to talk about.
And that breakthrough has a name, BERT. It was developed by Google, and its full name is a bit of a mouthful, but there's really only one word you need to remember, and that's bidirectional. Seriously, that one word is the key to everything.
Think of it like this. BERT doesn't just read a sentence from left to right. No, it surrounds it. It looks at a word, and at the exact same moment, it's looking at all the words that come before it and all the words that come after it. It's really the difference between just following a path and seeing the entire map laid out in front of you.
So how do you actually teach an AI to think like this? Well, you turn the whole learning process into a game, a massive, high-stakes game of guess the missing word. And there's a name for this technique. It's called masked language modeling.
Okay, so here's how the game is played. BERT gets shown a sentence, but a really important word is just blacked out. It's basically a linguistic puzzle. So BERT's mission, should it choose to accept it, is to use every single clue in that sentence, looking forwards and backwards, to figure out exactly what's hidden in that blank space.
And after playing this game millions and millions of times, using pretty much the entire internet as its textbook, BERT develops this incredibly deep, intuitive understanding of language. It's not just memorizing facts, it's actually learning the very fabric of how we all communicate.
But, of course, there was a catch. This incredible new power came at a serious cost. You see, BERT wasn't just smart, it was absolutely massive.
And to really get how massive we're talking, we got to look under the hood a little bit. The standard version of BERT has what are called 12 hidden layers. You can just think of these as 12 different levels of analysis, where each one digs deeper and deeper into the meaning of the text.
And each of those 12 layers is unbelievably complex, with a dimensionality of 768. Now, that's a pretty technical term, but what it boils down to is this. Each layer is looking at the text from hundreds of different angles all at once. The end result, a model with hundreds of millions of moving parts.
All of this complexity makes BERT, well, a bit of a diva. It's an absolute genius, but it's a resource-hungry one. It's just too big and too slow to run on your phone or your laptop. So that created the next big challenge. How do you get all of this brain power into a much, much smaller box?
And the answer to that challenge came from a really clever team at a company called Hugging Face, with an ingenious model they named DistilBERT.
Their solution was this brilliant process called knowledge distillation. The idea was, instead of building a whole new model from scratch, why not have the massive BERT model act as a teacher to a smaller, more nimble student?
So the student, DistilBERT, learns based on one really simple principle: just do what the teacher does. It's trained over and over to mimic BERT's answers, and in doing so, it absorbs all of its knowledge and intuition without having to carry around its massive size. It's kind of like learning from the master without having to become the master.
All right, so teacher versus student. How do they really compare? Let's break down the specs.
So on one hand, you have BERT, the teacher, bringing the full force of its 12 layers. It's all about raw power and getting the absolute maximum accuracy. And then you have DistilBERT, the student, way leaner with just 6 layers, built from the ground up for speed and efficiency.
I mean, DistilBERT is literally half the size of BERT, and this reduction is what makes it about 40% smaller and over 60% faster. But here's the most incredible part. It still retains 97% of BERT's original language understanding skills. It is an absolute masterpiece of AI engineering.
So, why does all this matter? Why is it so important? Because making AI smaller and faster is what lets it finally leave the research lab and come into your daily life. The truth is, this technology is already everywhere.
You know, every time you type a question into a search bar and you get that perfect answer back, that's a model like this at work.
When your grammar checker suggests a better way to phrase a sentence, or a customer service chatbot actually understands your problem for once, you're seeing the power of efficient AI in action.
In the end, the story of BERT and DistilBERT is about so much more than just two models. It really marks a crucial turning point. DistilBERT proved that we can have both incredible power and practical usability. It's the kind of innovation that took this cutting-edge AI out of a supercomputer and put it right in your pocket.
And this push towards smaller, smarter, more efficient AI is only getting faster. We've seen it completely transform our phones and our computers. So the real question is, what's next? If we have this much power in such a tiny package today, what is tomorrow's world going to look, feel, and even sound like?